Alrighty, I am sitting here in my oddly dark classroom to record the first lesson for our Unit 5 mini unit. So this is actually in our curriculum as being a part of Unit 5, but it doesn't necessarily have anything directly to do with radicals. And so what I decided to do was to split the radicals portion of the unit away from this. And so this is a small unit. It actually consists of about 3 different lessons. I think I'm going to spread it out over 4 lessons, but maybe 2 or 3 main concepts that we need to cover in this. So lesson 1 is operations on functions. So I want to review what function notation is. Everybody is familiar with function notation by the time they come to Algebra 2 because of the way our curriculum works, but not everybody is comfortable with it or confident that they know what the different pieces of the notation mean. And so sometimes there's this sense of just kind of winging it when it comes to the function notation. So I wanted to take a few moments and try to iron out what is this notation that we're using. So first off, what is the notation? I am going to No, I'm not. Just kidding. I thought I was going to change a display setting, but I'm not. So function notation is this. When we're referring to function notation, it's like the F, and then you have the parentheses, and then it says like X in parentheses. And the way that we read that is F of X. Okay, so that's how we would read that out loud, F of X. Now, a couple of things to know about that notation. The F is simply the name of the function. Okay, that's all it is. And because mathematicians are so unbelievably creative, because the word function starts with F, they name their functions F. That is literally all there is to it. Okay, like function starts with F. So that's why we end up with these function names F. Now, we do name them other things, and you'll see other things on this slide, actually. And then the X is typically, like the way I explain this is it just means that's the variable, okay, that we're working with. So it's the thing that's changing. It is the when you move and your lights come on in your classroom. Wow. Okay, so it's just like the variable, what we call the independent variable. And so F is the name of the function, and then X would be the variable in it. It is not multiplication. That is not F times X. And I am aware that it looks like F times X, and I get a lot of students that even towards the end of Algebra 2 are trying to undo the F and the X there, and it's not multiplication, so you can't undo it with division. Now, F of X is not synonymous with Y, but it is close, okay? And so you might have had a teacher in the past say F of X is the same as Y. And as long as you're dealing with a function, then that would be true. And most of the time we are dealing with functions. So anytime you see an F of X, you can replace it with a Y. I just want to be cautious because it doesn't work the other way around. So it is not true that every time you have a Y, you can replace it with an F of X. Okay, so that like substitution only works in one direction. But for the most part, yes, like F of X is another way of writing Y. You might have noticed when we're in Desmos, you can do Y equals something, or you can type in F of X equals something, and Desmos will read them the same way. All right, so what does it actually mean? So when we say Y equals F of X, when you see a statement like that, what it means is Y is a function of X. And you can actually see that in the way that it is displayed here. So Y is, our equal sign is often the word is, F is function, and then of X. Y is a function of X. There you get that F of X, a function of X, okay? Now that's not particularly helpful definition if you don't know what it means for something to be a function. So you kind of feel like, Ms. Taylor, we're going around in a circle here. So another way to put that is we could say Y depends on X, okay? That would be another way that we could express that. So in other words, some variable Y depends on this other variable X. okay, that might be changing. And as X changes, Y is going to change with it in some predictable way. And that predictable way is whatever the equation is, okay? We'll tell you how the two things change together. So that's what we mean when we say that. Now, here's an example. So we have d of t there. Okay, so d of t, we're obviously swapping out our variables. Typically, I think most of you would know, like when you see t in math class, usually that means time, because we see that enough. D could be a bunch of things. In this case, I intended it to mean distance. So we could say here, d of t means that the distance traveled depends on time. In other words, how far you go depends on how long you are going to be going. So if you get in your car, the longer you drive, the further you will go. Try not to overthink that relationship. A lot of these are relationships you deal with all the time in everyday life. So you get in your car, the longer you're driving, the further you'll go. Now, don't overthink that and say, well, what if I get a stop? I hate every stoplight. Okay. I know stoplights happen, but the idea is, you guys know that I run. So the longer I am out there running, the further I will be able to go. Distance depends on time. Distance depends on how long. And the way that is expressed mathematically would be in that function notation. So you're expressing a very specific kind of relationship that wouldn't necessarily always apply to a y. Now, there are other common function names, okay? And I can't see what the next one is. Oh, shoot. Okay, that was not good. So there are other common function names. I'm not going to rewind this video and do that because I am already 7 minutes in. But other function names that you will see a lot of times, I'm going to make the notes up here. You'll see g of x. You will see h of x, okay? And literally that is because they come after f in the alphabet. So you have A, B, C, D, E, F, G, H. That's all there is to it. Now, when we're dealing with specific like word problems, then we will name the function after whatever is in the word problem. So I just had one up there that was d of t. And so what you do is you're going to swap out the name of your function for whatever it is that you're measuring. You might see something like velocity depends on time or so forth. I had a graduate professor that would do this, especially if he thought we weren't paying attention. He would name his functions Bubba. So if you saw my notebooks from grad school, you would see Bubba of X, because you can name it anything you want. Like Bubba depends on X. I don't know what Bubba is, but it depends on X. Okay, now, so that should have gone on the previous slide. I apologize for that. Sometimes I forget the way this works when I'm teaching it in class. It does not work when you're in the recording, so very sorry. All right, so there are 5 main function operations, and you can read them down the side there. We have addition, subtraction, multiplication, division. Everybody's like, yeah, cool, good. Add, subtract, multiply, divide. Been doing that for a long time. And then you have that one with the double asterisk down there, composition. That's a new one. That gets its own lesson because that's going to be brand new material. But everybody here does know what adding, subtracting, multiplying, dividing are. If you aren't, we need to talk about whether or not Algebra 2 is the best place for you to be. So for addition of functions, pretty much all that means is that you're going to take function f and add it to function g. Okay, that's literally all it means. And the biggest part of this lesson, actually we had to add some different stuff to this lesson this year, is getting to know the notation. So you'll actually see it as f plus g of x. Okay, so you see it either way. You could see f of x plus g of x, or you could see the f plus g of x. Now I am aware that that looks like you factored out an x. It's not what happened, but it does look that way. Subtraction, this is going to be absolutely shocking to everybody. So you could subtract them. Okay, and your notation could be written as f minus g. of x. Now, just be aware that when you're subtracting is not commutative. So you could see g minus f. We kind of get in this habit of writing the f first because f comes before g in the alphabet, and so we're just always writing f is first. But when somebody is presenting a problem to you, they could present it in either order. So you just want to make sure you are paying attention to that. Multiplication is when you have f of x times g of x, or f times, and I keep getting that, f times g of x, and now my little dot went away. Okay. Yeah, f times g of x. Sometimes you will also see them like right next to each other, like f and g. So the multiplication would be implied. I don't know if I have that later in this lesson or not. You think I'd remember because I just did the PowerPoint, but you know, it's at the end of school day. So we have f times g. Now I do want to make it, well, we'll look at that in a second. Then we have a division. So that would be your f of x divided by g of x. And again, this is not commutative. So just pay mind whether somebody is doing f divided by g or g divided by f, okay? Because those would not be the same. You can also see this written as f over g of x, or you can see the sideways division like that. Okay, so all of that would work to be a division symbol as well. And then the last one, that's good. This is going to be in another lesson. So everybody does know what a plus sign means and everything, and we've actually done all these operations before. Composition is new, so composition is going to get its own lesson. That composition is plugging one function into another. So it actually looks like this. F, and then instead of x, you put the other function on the inside. So it's f of g of x. And half of you are like, why would I ever want to do that? That seems like a terrible idea. It does have its uses. Now, the shorthand for that one is this. Okay. And I want to point something out, and that is, notice that the time sign has to be a solid dot. Composition is an open dot. So take a moment in your notebook if you're watching from home and just pay mind to that. Like, they are two different symbols. Every single year I will give a composition problem and someone will do multiplication because they don't realize that it's a different symbol. Sometimes we do refer to this as fog because it does look like the word fog, but it is composition. Now, off here to the right, I wrote, often the x is omitted from the notation. So a lot of people are very uncomfortable with this, like, of x. Like f plus g of x, f minus g of x, f times g of x. All that x means is that x is the variable in whatever it is that we're dealing with. But lots and lots of people are uncomfortable with it, or it causes them to make mistakes. The rest of the people that are not uncomfortable with it still don't always want to write it because it feels like extra writing. So a lot of times we might write something just like f plus g, or f, or like, I don't know, g, I was going to do a composition symbol there, g composed with f. And so a lot of times you won't see the of x there, and that's totally fine as well. I don't know at this point what to expect on your final, whether you're going to see the of x or not. I personally am totally okay if you want to leave it off. In fact, if it's going to cause you to get something wrong, I would rather have you leave it off. That a lot of us will just kind of drop that of x because it's not necessary to understand the context of the problem. So that notation would be okay. All right, so I'm going to do some examples here. I actually have 4 examples done out, and I don't know how I'm going to do this in class. In class, I might stop and have you guys do some practice or something. Actually, I think there's separate practice for these ones. So for these types of problems, you do need to have the two functions defined for you for every set of problems. So they'll often come in like a set, like for this set of problems, this is what you're going to use for F and this is what you're going to use for G. And then you get down to the next set of problems. This is what you use for F and this is what you'll use for G. So in this one, I did opt to drop off the of X, and that was for convenience. So that's what we're going to do. So we have F plus G. So I'm going to take function F, which is 2x plus 1, and add to that function G, which is negative x squared minus 3x plus 2. And you might say, that looks like something we've done before. Yes, it is. So this skill you have actually already done on your polynomials. So just removing the parentheses, we have 2x plus 1 minus x squared because it's negative minus 3x plus 2. And then we'll combine like terms. We have no like terms with the x squared, but we do have 2x minus a 3x, which is going to give us negative 1x, or simply negative x. And then we have 1 plus 2, which would be 3. And that's all you would do. To subtract, we're going to do F minus G. So we have 2x plus 1 minus negative x squared minus 3x plus 2. Okay, and then we'll go ahead and remove those parentheses. They are not cosmetic here. So minus a negative right in there is going to turn this into a plus x squared. And then we have another minus a negative, which is going to make this plus 3x. And then we'll have the minus 2. And then as before, we're going to combine the things that are the same. So we don't have anything with the x squared, but we do have a 2x plus a 3x, which is 5x. And then we do have a 1 minus a 2, which is minus 1. Last one is G minus F. Actually, there's one more on the next page. So G minus F. So to do G minus F, this time I'm going to start with, and I'm really afraid I'm not going to fit this, we're going to start with the G, negative x squared minus 3x plus 2, and subtract from that our F, which is 2x plus 1. And then make sure you do that step of removing the parentheses. So we'll have negative x squared minus 3x plus 2 minus 2x minus 1. And now we will combine our like terms. Once again, that x squared just doesn't have anybody to hang out with. Negative 3x minus 2x is negative 5x. And then we have 2 minus 1, which is 1. And now take a moment and look at the answers for F minus G and G minus F. Just like look at those two answers and think, do you see any connections or patterns with that? I'll wait. Right. And what hopefully you notice is that they're the same, but the answers are everything's the opposite. So you had a positive x squared that in the other direction is negative, a positive 5x, which is now negative, and a negative 1, which is now a positive. That is not a coincidence. So if your question is, that was interesting, does that happen every time? Yes, that actually happens every time. And that can be a nice little thing to know if you've got some kind of subtraction problem where you have to switch the order of the subtraction, that it's just going to flip the sign of everything. On a more basic level, if you had like 7 minus 4, that would be 3. And then 4 minus 7 would give you negative 3. That will actually happen all the time. All right, if I can find my mouse. There it is. So the last one here is F times G. And again, just notice that it does have to be a solid dot. Okay, it can't be like bubbly dot or anything. And so for this one, we are going to multiply. So I'm going to be consistent with what we've been doing. I'm going to use the area model. So I'll have 2x plus 1. And then we will have negative x squared minus 3x plus 2. And then we'll multiply everything in each box. So this would be negative 2x to the third. This would be negative 6x squared. And this would be 4x. This is negative 1x squared, negative 3x, and positive 2. And as is often the case, not all the time, it depends on what form your answer is in, but our like terms are on the diagonals. So when we go to add them up, we have negative 2x to the third minus 7x squared plus 1x plus 2. And there's our multiplication. Ta-da! As always with these videos, pause at any point if I'm kind of whipping through the video there and you need to complete your notes or write something else down or make an additional note. That's the good thing about a video is you can rewind it if you need to. Okay, so these are some practice problems. So what I'm going to ask you to do is pause the video right here. These are a little bit easier. I gave you 2 linear functions instead of having a quadratic in there. So a little bit simpler to do. So take a moment, pause the video, work these out, and then unpause the video when you are ready. All right, so on the next slide, I believe we have the answers. And we do. So let's take a look at that. So f plus g, you've got 3x plus negative 8x, which is negative 5x, and then negative 4 plus 1, which is negative 3. So your sum would be negative 5x plus 3. G minus f, make sure that you are going in the correct direction. So that's going to be negative 8x minus 3x, which is going to give you negative 11x. And then 1 minus negative 4, which would be 1 plus 4 or 5. And so our answer to number 2 is negative 11x plus 5. That's a little bit hard to see there, but that is a plus. The multiplication, this requires some scratch work. So I'll buy that maybe you could do the first 2 in your head, but not this one. So you would have like 3x times negative 8x, which is negative 24x, x squared. And then you've got the middle piece. So you'll have 3x times 1 is 3x, and then negative 4 times negative 8x, which is positive 32x, and then you'd add those together. So you would have 32x plus 3x, which is 35x. And then negative 4 times 1 is negative 4. So your answer there is negative 24x squared plus 35x minus 4. Now, for number 4, we did not do an example problem that had division. So you might have just set it up. And if you set it up, that would have given you 100% points. So if you didn't do it because you weren't sure of where to go with it, make sure that you are trying it. You know, practice problems are low stress. Those are low risk. So all you need to do is set that up. Now, it does say underneath there, if it is possible to divide the polynomials, do so. The one on your homework will be doable. So when you go to look at your homework for this particular lesson, when you set up the division, it is going to be something that's dividable. And so you should whip out your area model and go ahead and get that division done. Now, something that is new this year is one of the things we're assessing is whether you can do these kinds of things given functions that are in various forms. So typically we really emphasize the equation form of the function, and we do what we just did, the operations on the functions in the equation form. But you can also see functions displayed as tables and graphs and something called a map. So the rest of this lesson is just going to take us through how would we deal with other forms of a function. I apologize for the formatting on this slide. So I have like 1, 2, 3 example problems like that, and then these two. And because I needed that time sign, I had to go into a different program to type the time sign, and it bumped them to the middle, and I couldn't get them to go back. So what I'm going to do is work the first 3, and then I forgot to make these f's negative, or not negative, but lowercase. That's no big deal. It actually doesn't mean anything at all. But, and then I'll let you guys do these 2 as practice so you can see if you can follow along. So when you have a table, and these tables can be set up either horizontally or vertically. Okay, so you could have like x, f of x, g of x in these like little columns. This one has them set up in rows. So this tells you the x value, and then this tells you the f of x or g of x value that goes with it. So that's a great lead into this first problem, which is just what is f of -1? So x in this case would be -1 if you're looking at where I am hovering my cursor there. X is -1, so you're going to go over to -1, and then you're looking for the value of f of x, which would be 3. So the answer to that would just simply be 3. F of -1 is equal to 3. In other words, when x is equal to -1, y is equal to 3. So if you were going to graph that, it would correspond with the point -1, 3. Okay, just so you know, because the next thing we're going to look at is a graph. For the next one, we actually have some operations in there. So we are going to multiply f of 0 times g of 2. So remember that this number inside the parentheses tells us our x value. So f of 0, I'm going to go across here, find 0. F of 0 is equal to 1. And then I need to go find g of 2. So same deal. This is my x value. So I'm going to come over here. And this time I have to just make sure I go down to g. G of 2 is 4. So that is a way of writing 1 times 4, which is just equal to 4. Okay, so f of 0 times g of 2 would be equal to 4. Try not to make this like more complicated. Now, this next one, I altered the notation a little bit. So we have f times g of 1. And what that means is that we're going to talk about 1 for both of them. So you might want to do a little rewrite on this one. This is actually f of 1 times g of 1, if that helps. Okay, so that just means that we're going to use 1 for both of them here. Our x value is 1, so we're going to come over here. F of 1 is -1, and g of 1 is 1. So we will have f of 1 is -1, g of 1 is 1, and when I multiply them, I get -1. So right here, pause the video. I know this is probably new for most of you. This is not a conventional way. It's new for me. I mean, it's not new for me. I can do these problems. I just don't usually teach this. So this is like a new way for me to teach it. So pause the video, see what you can do with those last two. That's f of -2 plus g of 0 and f minus g of -1. And then unpause it and we'll go over them. All right, so on this one, f of -2, there's my -2, f of -2 is 5. And I'm going to add to that g of 0, which is 0. So that is 5 plus 0, or 5. This last one, f minus g of -1, you want to remember that that means that both values are going to be -1. So we're going to be looking at this column right here. So f of -1 is 3. Oh, and I copied that one. Hang on. That should be a minus. There we go. And g of -1 is 1, and 3 minus 1 is 2. So if you were able to get 5 and 2 as your answers, then yay, you've got that from the table. Okay. Let's look at the next one. So this is another way you might see functions represented as a graph. So we're pretty familiar with that. So you might see f of 1 minus g of 0, and you are asked to get this from the graph. Now, this is really tiny. I don't even know how this is going to work in class because it's super small, but I did label them. The purple one is f. If you look at where my cursor is, there's a little f there. If you're watching this on your phone, good luck with that. This is an f for the blue function, and then the g over here is labeling the red function, because if you're going to subtract them, it actually does make a difference. Like, you got to make sure you're pulling the right numbers in the right order from the right functions. So for f of 1, remember that that means that x is equal to 1. Now, the scaling on this is maybe not ideal. So this is like 2 over here. So this means this is 1. And I'm going to go up and find the value of that blue function when x is 1. And that puts me right here. And I can see that the value would be 2. So f of 1 is 2. Essentially, what you're doing is you're saying the x-coordinate of the point is 1. Find the y-coordinate that goes with it. F of 1 is going to represent the y-coordinate. So x is the 1 is the x-coordinate, and then what's the y-coordinate? In that case, it's a 2 because it's right there. Then we're going to do g of 0. So we're going to go 0 is the x, and this time I'm looking for the red function. And I can see right there it's halfway between the 0 and the 2, which would make it a 1. So essentially that problem is 2 minus 1 or 1. So for funsies, try to do the next one. That's f times g of -1. Notice I omitted the dot that time. Okay, and just went with fg because you can see that as well without the dot. So try that next one. Just see what happens. I know this is probably a new kind of problem, but pause the video, give it your best shot, see what you can do with it. Okay, so we've got f times g of -1. So this is going to be f of -1 times g of -1. And so what that means is our x-coordinate there is going to be a -1. So coming over here, if you can see where I'm marking up my graph, there's the -1. F, of course, is our blue function. So we're going to come over here, and there it is. It's up at the 2. So that's going to be 2. And now I have to do the same thing with that g. So coming down here, this would appear to be at -1. So that's going to be 2 times -1 or -2. All right, so we've done how to do it with an equation, how to do it with a table. This is a graph. The last one we're going to look at is something called a map. And maps are not super common, okay? They are not super common, but when they are common, they are very useful. So what they do is they actually show a mapping. If you guys ever take any higher level math, the idea of like a mapping one set onto another set becomes very important to how you understand like what functions are and how they're related. But essentially for everything you guys need to know, remember domain is your x's and range is your y's. So you're always mapping an x onto a y, and what you'll see is like this little bubble with a bunch of x values, and then the arrows are going to tell you what the y value is that goes with it. Okay, and once again, you do have to have them labeled. So this is f, and this one is g. So we are looking in this first one for g of 10 divided by f of 0. So g of 10, I'm going to come down here. Remember, the number in the parentheses tells you your x. So g of 10, this is going to tell me what it maps to. So it maps to a 30. So we are going to have 30 over or divided by f of 0. So make sure you know which one is f. That's f right there. Okay, f of 0. So here's the 0 for my x coordinate, and I'm going to go across, and that would be a 3. 30 divided by 3 is 10. Next one is f of 3 plus g of 2. So we come over to our f, and we look for 3. So an f of 3, so when x is 3, y is going to be 21. And then I am going to add to that g of 2. So I come down here to function g, and that g of 2 is mapping over there to a 6. And so 21 plus 6 is 27. Okay, now because I do want to give you guys a chance to practice this. So you've seen 2 of them done out. You can rewind the video for a whopping 2.5 minutes and watch me do them again if you want. Then pause it and try to do g minus f of 2. And then unpause the video and we will go over g minus f of 2. Okay, so when we're looking at g minus f of 2, we want to remember that this is going to be g of 2 minus f of 2. And so looking at g, because we do have the g first, okay, g of 2 is 6. We just got that one up in the previous problem. So g of 2 is 6. And we are going to subtract from that f of 2. So we come up to f, we go to 2. That maps over to 11. So we're going to be doing 6 minus 11, which is equal to negative 5. Now, if you did 11 minus 6, that means you subtracted in the other order. You did f minus g instead of g minus f. That's like one of those little careless things, like I wasn't quite paying attention. And you can fix that. So that concludes this lesson on operations of functions. I think we had some review stuff, we had some new stuff, and if you have questions, you always know how to reach out to me with those questions.